Hey everyone, this is Mrs. Hilt, and I'm going to walk through numbers 12 and 13 from the F equals MA practice problem set. All right, so number 12, an object of mass 30 kilograms is in free fall in a vacuum where there is no air resistance. Determine the acceleration of the object. So at first glance, this doesn't seem like it has enough information to solve it, because in all the other problems, if we're given mass and need to find acceleration, some force would be given, but there isn't a force. So we need to think about what's actually happening in the problem. We just have an object that is free falling and there's no other forces acting upon it. But what is the force that's acting upon it if it's free falling? So think about like if you dropped if you're holding something right now, a pencil maybe. If you just drop the pencil, it's going to go downward. And why? Like what's pushing it down? I hope you guys are thinking or said gravity, and that would be right. Gravity is pushing it down. So the only force acting upon this object in number 12 is gravity. Oops. Let's draw a free body diagram, F gravity. Right? And the acceleration of gravity, because it actually is an acceleration rate, is 9.8 meters per second squared. All right, now number 13, very similar. We still have that 30 kilogram object, but it is experiencing a force due to air resistance. So I'm going to bring that box back down because it's still falling, like it said. So we still have gravity acting upon it, but now we have air resistance. Okay, and I did not draw those arrows to scale, by the way. Okay, so we have F up and an F down. So let's try to answer these questions. Determine the net force and calculate the acceleration. So the force was given to us for the air resistance. I'm going to put that right here. F equals 50 newtons. Now let's figure out what the force would be down here. Okay, and now we do have enough information to solve that because we have 30 kilogram mass, and we know that it is accelerating downward at 9.8 meters per second squared. So the force that we calculate with this is 294 newtons. Let's go back over here and write that in. 294 newtons. Okay, so if we need to calculate the net force on the object, we have to find the difference of the two. So 294 newtons minus 50 newtons. So the net force acting upon this is 244 newtons. Okay, now what is the acceleration of the object? So to calculate the acceleration that the object is going at, we have to consider all of the forces. So now that we have the net force acting upon this object, that is the consideration of all of the forces. So we will use this force and the mass to figure out what rate this object is accelerating at. All right, so acceleration is equal to force divided by mass. So that means that this object is accelerating downward at 8.13 meters per second squared. And I would say that makes sense because if gravity is going down or has a acceleration of 9.8 meters per second squared, and we have some air resistance going in the other direction to cancel a little bit of that out, it makes sense that our acceleration rate downward would be 9 or about 8, so a little bit less than the acceleration from gravity. All right, let me know if you guys have any questions.